Now I'm gonna go over how to do the data analysis for the task 2. Task 2, you need to make the graph of pH versus volume of sodium hydroxide in mLs. Okay, and then I want you to have the graph on the whole page. Okay, and the landscape. And you have to choose the one, the XY scatter, but this time choose the one connect the data, each data point. Okay? And then also you need to have the grid line on the horizontal line and the vertical lines, major and minor. Okay? After that, you are ready to do the data analysis on the graph. We're gonna use the data analysis, which is called the geometric method. We're gonna use the ruler and measure the distance and determine the equivalence point. And the midpoint. That's our goal on this graph. Okay? First, I want you to use the ruler. Okay? So I pretend this one is a ruler to draw the line. So first, you need to draw the line on the flat around the pH 11 to 12. Okay? And then also you need to draw the straight line on the buffer region, which is also give you the flat line. Okay? Like this. And then the last one is the vertical lines you need to draw, which is cross this steep jump. Okay? And then you get the two intersections from those three lines. One is the top one with the bottom one. Okay? And then you need to measure the distance between those two intersections. And then get the midpoint, okay, between those two intersections. The midpoint close to your pH graph. That's your EP, equivalence point. Okay? And then you need to also draw the vertical line from the equivalence point to the x-axis. That's the one volume of sodium hydroxide at equivalence point. Okay? I want you to label everything on your graph like this. Okay? And then next, you need to find the midpoint. Midpoint is the one that the half volume from the equivalence point. Let's say this one is 40 ml. Then the midpoint is gonna be half, which is 20 ml on your pH graph. So from 20 ml x-axis, you need to draw back the vertical line to the graph. Okay, so this is the midpoint, and then you need to find the pH of the midpoint. This pH equal to the pKa for your unknown. Okay, so you need to label everything like this on your graph and turn it in. Okay? After you do this, you need to calculate the molecular weight of your unknown. Okay? And then again, you're gonna use the concept, which is moles of acid equal to moles of base at the equivalence point. Moles of acid is your unknown, and then everybody weigh out is about 2 grams. Okay? But you should use your own mass that you weighed out on the balance. And that divided by molecular weight equal to the sodium hydroxide concentration from the task 1 you just calculated. Okay? That times volume of sodium hydroxide at equivalence point. That's from your graph here. Okay? So now you can solve for molecular weight. Okay. Based on the molecular weight and this pKa, there is a table for the possible unknown, which is page 79. Okay. So there's a 79. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 possible unknown acids. So based on your molecular weight and pKa, you will determine the identity of your unknown. And there is a chemical formula. So based on the chemical formula, you can calculate the Lagrange value for the value of the molecular weight. And then Ka, there is a Ka. So you convert the Ka to the pKa, which is the pKa equal minus log of K. It's like a pH. And then compare to your result. Okay? That's all you have to do for the task 2.